I hit the wrong overlay. The camera is working fine, I think, as is the microphone, but let's give it a check. I think the microphone needs to get a little bit closer. And we need to lower the music a bit. Like that. Good evening, folks. How are you tonight? Yeah, as Dutch Taurus is saying, I finally got a 3090 for my desktop, and I've been having nothing but issues with it. I had a 4070 Ti Super, worked great. I could leave my PC on for days and play games and video edit and do my PCB work and all the other work I need to do. No problem whatsoever. I slap a 5090 in there, crashes like 8 times a day, or sometimes I can play a game for an hour and then sometimes it's 5 minutes and I get a black screen for no reason whatsoever. Sometimes I get a black screen on the desktop. Sometimes it black screens and reboots. Sometimes it black screens and hangs. It's just all kinds of weird issues. Now, I just, before the stream, took everything out and reseeded everything. And after that, it seemed to be a little bit better. But I have no idea. So I'll continue and investigate that. But so far, my RTX 5090 journey is very shit. The performance is great when it doesn't crash. And sometimes it doesn't crash for hours. And then sometimes it crashes like 3 times in an hour. No idea. So yeah. So good evening all. It's been a while. Let's see who's all here. Nigel Young was the first one. And then Jacco Wies came in. Little sensors would be great to get working with Quinn stuff or ESPs. Yes, well, for sure. And my boards, like Jacco also pointed out, expose a lot of GPIO pins, so you can do that with them. But the question is if these sensors that I selected to test today will actually do that. Because officially, they need 12 to 24 volts. And while my boards don't easily expose that. So that's going to be interesting. Music. Dutch Taurus is here. Kvik. Hey there, Kvik. Welcome. So my camera still seems to be working. That's nice. Do we have... Oh, I think we have to go here for the overlay. Does this work? Yes, it does. Oh, look at that. We have an overlay. Good. Awesome. Let's see how the CPU usage is doing. We should be okay. Yes, we are. Good. Perfecto. Very nice. So it's probably not going to be a long stream today. I recently got back from China. And it was a good trip, but it was exhausting. Yeah, I'm still kind of trying to rest up this week and process everything in my brain and make a good plan going forward, basically. And that's taking a lot of brain space. So today we're just going to have some fun with some sensors. It might work, it might not. And then we'll see. So how are you all doing? Did you miss me last week? I wasn't here. Well, I literally wasn't here, but I also wasn't streaming or didn't have a video, so... I'm checking if everything's going okay. I think so. Yeah, everything seems okay. My NVMe drive is very busy. What are you doing? It's writing with 50 megabytes a second. Of what? Why? Why are you writing to my disk at 50 megabytes a second? I mean, my video recording isn't 50 megabytes a second. Is it downloading some update? No, it's not. What? I don't understand. That might be why my system feels a bit sluggish. What are you writing? How do I see that? I don't think I see that. Can I see that? Disk. System. The system installer worker is writing to my disk at 50 megabytes a second while I'm streaming. I wish you wouldn't do that without asking me. It just, it just does it. Doesn't care. Well, let's hope it stops in a minute. Oh, one of my cores is also full. That's probably why I'm seeing some slowdowns. Okay. Okay, Windows. Jeez. The CIA is watching your drive. That's 50 megabytes a second. Yeah, exactly. Well, it's slowed down to 45 now. What? One core is still full? What are you doing? Okay, let me check Windows Update. Oh yeah, it's installing the cumulative update for Windows 11. I didn't ask for this. It's fine. Maybe do that when the computer is idle, but currently I'm streaming with like multiple 4K cameras and things like that. Let's see. Pause for 5 weeks. Your device won't be up to date until updates resume. Yeah, fine. I'll update when I update. Still, it's just continuing. Doesn't stop at all. This is a good time for an ad. No. It's your new driver for the 5090. Oh no. This is a different system. This is my streaming system, and well, it's my workbench and streaming system, and that's the only things it does. I don't touch it during the week, and it's stable and it stays like that. Oh, it peaked to 400 megabytes a second. Okay. Oh, now it's done. Okay. How's the CPU usage? Yes, CPU usage is now much better. Good. What the hell, Windows? Okay, well, now I'm fully here. That's nice. No, this is the one I upgraded with a 5070 Ti. So I have dual AV1 encoders in good quality. And the 5090 went to my desktop, partially because I need the memory for DaVinci Resolve. Having more video editing memory really helps applying some effects. And it has a triple video encoder and dual video decoder, which also really helps in the workflow I have. So yeah, and also better quality and more speed and etc. etc. Some renders I test rendered that didn't get stuck for some no apparent reason. They rendered 3 times as fast. So instead of me waiting 45-50 minutes, it was like 15 minutes. So that is a really big improvement. Others, went from like 12 to like 9 minutes or something like that. But it's those more complicated projects with like 10 timelines and multiple overlays and effects and things like that that really eat up the video memory and the video processing. So that's why I had a 3090 before. I made a side step to a 4070 Ti Super. That's now in a different PC, and well, the 5090 is there for the video editing. Yeah, and I do play games sometimes, so it doesn't hurt there. Except when it's unstable crap. Then it's totally useless. So, yeah. Anyway, enough complaining about a way too expensive video card that isn't even working correctly. Yeah, are we done updating? I think so. Yes, good. Now everything's nice and stable. Good. See, I like the smooth performance. No, that's actually not smooth. Is it smooth on your side? I don't know. Here it's not smooth, and no, still not smooth. What? Why are we not 60 FPSing? I don't know. I don't know anymore. Okay. Anyway, let's hope it's just a preview that isn't smooth. I've dealt with that before. So, I didn't maybe start it as administrator. Okay, well, we'll have to deal with it now. Can't help that. Let's see what priority mode we're in. High. That's good. Okay. Anyway, today we're drinking the last Fanta Zero Sugar Raspberry I have right now. I don't remember if this is a limited edition or not, but we're drinking that. Yes. Uploading data to the motherland. Yes. Astrom, you're very welcome, and thank you very much for the kind comment. And Kvik, I don't think right now there's going to be a video. I did make some videos and some photos. I guess I could make a video from that. But currently the chat overlay is gone. What do you mean? No, oh, okay. I had to turn it off and turn it on again, and now it's back in full. Okay. No idea. But yeah, I did shoot some stuff, but this was really a one-purpose trip, and I spent most of the days in the lab where I wasn't allowed to film and video and stuff like that. So I don't think so. Maybe there will be some snippets here and there in a future video, but as of right now, I don't have a dedicated video planned. So, yeah. Mori Brewery Zero Drink, absolute blast of a taste. Okay, sounds nice. Okay, let's get this out of the way. Good. Oh, we still have some minutes before we begin. Stream until you get a black screen. Oh, exactly. That's why I'm not using my desktop. Non-alcoholic, zero flavored. I don't know what zero flavored means. I'm going to Google this. Zero flavor. Jira flavor. Any house updates? Yes, the house updates are that I haven't worked on the house for the past few months because I've been really busy and kind of, I don't know, bumping up against working on it. It's hard to explain, really. But because it's a really big project, I got stalled, and it's kind of hard to pick it up again, I guess. I'm going to plan on doing that next week again, now that I've got some other stuff out of the way. That's why I went to China. And those plans are moving. But yeah, so no house updates yet. Thank you, Medved. So let's wait another 5 minutes for people to come in. How are you doing, Quindo? I'm okay. I'm a bit busy in the head, so I'm a bit all over the place. But you know, trying to take a little bit easier after a very busy last week. Can you tell us what your visit to China was about, or is it a secret? It's not a secret. Basically, we've been doing CE testing to try and get most, or at least everything, most of the product officially certified with lab results, etc. I know you can self-certify for CE, and that's what a lot of companies do. They don't actually test their shit. They basically say, it'll be fine, and then when they get tested and it isn't fine, they're like, oh, we didn't know, no. I don't like that approach. I want, if I say it's CE certified, I actually want it to be fully CE certified with all the test data to go along with that. So I've been working towards that for the past year or so. And a few months back, I was making a guide for my partner in China and AllNet China on how to test everything and things to test and try and blah, blah, blah. And after page 7, I was like, okay, I can keep writing this ginormous document of what they need to do and how they need to do it, or I can just go there. And a round-trip flight to Shenzhen is €550. And then a hotel stay is about €500 or €600 too. So let's say with food and everything, because food is really cheap over there, I'm out $1,500, right? And then I'm there for a week, and I can actually go to this lab myself and spend a few days there and testing things and actually learning, like, okay, what if I change this in the circuit? Or what if I change this in the settings? Or what if I do this different or that different? And I already had provisions on my board for components I could change or alter, or empty pads and things like that. So I went there myself and dove into the lab to do conductive emission testing, radiated emission testing, and EMI testing, I guess. Basically, they zap your boards with 2, 4, and 8 kilovolt of electricity. So that's basically what I went and did there. We did hundreds of tests, and that actually taught me a lot, like what changes in the circuit do what for conductive or radiated emission and stuff like that. So for the results, you'll hear more about that later, but conductive emissions, everything I make passes, that's no problem. ESD, or zapping it, it depends on the product we're talking about. The products without a case, well, if you zap a chip on the board or a direct data line to the ESP, yeah, it's gonna die. I mean, what did you expect? So, the products that are encased, they all passed, and the products that aren't encased, some of them did, some of them didn't. And for radiated emission, and that's the hardest one in my opinion, most stuff passed, but some stuff might need a small alteration or a rethink in that sense. But yeah, most of the stuff also passed for that, so that's good news. Now that's all pre-certification testing, as they call it. So it's basically testing, doing all the tests and giving you results and graphs and things like that, but not actually a certification yet. You then pay a lot of extra per product to have official certificates made. It's like a 20, 30, 40 page document with all the test results and everything in there, stating that it's officially certified and tested and blah blah blah. So we're moving ahead with that for certain products that will then have full CE tested results. And then, well, you can guess where it's going. I will be opening a shop in the Netherlands at least, or at least with a partner here, and likely also in the EU. So yeah, that's the idea. So Kavik, hopefully that answers your question. What are you talking about, Medved? I have an AMD laptop I've been very happy with, but it has an RTX 4060, so yeah. Yeah, so I'm not sure yet what it's going to do with prices. I've always said that even if I start selling here locally, that doesn't mean things become cheaper, because there's now a lot more steps involved than it is if you buy it directly from China. And even just the certification itself, the certification per product, if you do it here in Europe, is about 15,000 euros. Yeah, in China it's a lot cheaper, but it still costs a lot of money, especially if you have a lot of products. And then if I have to get it here, I have someone unpack it, store it in a warehouse, run a web shop, do payment processing, and then repackage it and then ship it to you. Well, that's already double shipping costs. There's input fees, stocking fees, handling fees, yada yada yada. All extra costs that aren't there if you buy it directly from China with AllNet. Now I know AllNet shipping isn't cheap. Shipping isn't cheap. But I mean, I have to ship it here. I still have to ship it here. Now bulk shipping can be cheaper, sure. But if you then have to ship it again, and all those extra costs, I think it'll be pretty close to the price it currently is. Tax is the same either way. But yeah, we'll see where it ends up. I'm making the move. We're gonna do it, but I don't know if it'll help in prices. But we'll see. Cool. I talked long enough so that now I can start. Okay, let's go to the desk. And this camera is a bit a bit dark, isn't it? There. Should just ask Philips to produce them in Netherlands for you. Yeah, then you get Philips Hue prices. And a downgraded product. So you get half the product for triple the price. If that's what you want, you can just buy Philips Hue. I mean, you know. So, we have these little envelopes here. And I saved these from a Quinbox. So we're going to unbox them now. And they should have some sensors. Now, those sensors are linked in the video description. And officially, these are 12 to 24 volt sensors. But they're a really interesting way that they did this. So I wanted to see if they could maybe potentially also work at voltages, you know, the board supports, and that's 3.3 volts. So the chance is pretty slim, but we're gonna try anyway. Because then it'd be really cool to use these sensors, but I have no idea if it's going to work or not. Oh, alright. There. Okay, let's put these in here. Alright. So, yeah, see, it says here DC 12 to 24 volt. Yeah, I have no idea. Mini 1215, okay. There's various types. Exactly, Guido. I'm afraid of that also. But, let's see. Which one are we going to unpack? I guess we can just unpack this one. It would be cool if it would work. If it doesn't, well, you know, that's fine. Okay, they have a little clip. Oh, and a screw. So you can screw this into your closet or something like that. Okay. And then these sensors basically clip in here. I think, yeah, like that. And that's a pretty neat solution. If we can get it out again. Yeah, I have no idea what they use inside. Yes, they are normally used for LED drivers that are for cabinets and stair lighting, but I don't know if they actually require the voltage they say they do. And that's what we're going to test. I thought these were, they are, I think. Yeah, I was going to say, I thought these were modular, so that is also nice. I like that these are modular, so you could actually just, you know, use multiple types on a cable. The good thing is, I can now snip this cable and then test it. Now, if we look at the cable, let's see here. If we look at that cable, we see I think this might be positive, negative, and then data. But I have no idea because I don't have the original controller. Might be Medved, might be, yeah. Is the music low enough or is it disturbing when I don't talk? So how do we test what voltages we need? Or, I mean, what pin does what? I can't really tell. Let's unpack another one. Okay, so this is I guess a distance or line sensor. But again, they have the nice. Okay, I'm gonna turn the music of the PC down. Okay. But yeah, they still have the nice disconnectable connector. Let's see if we unpack them, if we can get a hint. If we can get a hint how this is connected internally. Sticky goo. Oh, this one has a little block in here. Okay. 12 volt. 60 watt. 24 volt, 120 watt. Oh, this one can actually switch then, I assume. So it can do 12 and 24 volts, and then it can switch a certain amount. And then they have the same sensors attached again. That still doesn't really tell us what wire does what. Some are inline controllers. Yeah, same thing. This one is a button, I think. No. Oh, this one seems a bit damaged. Not sure it's supposed to be like that. Okay, I had another one of these. This one here. Not sure what the difference is, but at least we have two, so we can wreck one. Okay, so let's take this guy, and well, I need to know what wires to apply power to. First off, let's snip off this connector. We don't need this connector. It's only in our way. And we have enough of these cables now. So, bye-bye connector. I think the desk needs more light. No. Oh, I can give it a little bit. There. Okay, yeah, that's better. Good. And let's get the wire strippers. Okay. Right, so we have 3 wires. Okay, let's get the power supply wires. So I hooked up the variable bench power supply, and I think we're just going to give it power and then see if the other wire is going to give us measurements or not. Now, if I look here, it's very hard to say what wire does what. I don't think it says on there. How would I wire this? I think I would have ground in the middle, and then positive on one of the sides. But which side? Could I measure this? Let me think. I don't think we can easily measure it either. You're betting on switched wire in the middle? Yeah, possible. I mean, I'm looking at the wire, but the wire is not going to tell me anything. It's just wire, right? So, oh, maybe we can open this up. Yeah, there's a clip here. Let's see. Oh, might have gotten it. It's a good thing I didn't clip my nails yet. Oh, I need to get another one here. Almost. It's going. Oh, okay. Oh, wow. Look at how hard I was pushing. Okay. Well, it came apart. So now we have a little PCB here. That's interesting. Okay. So can we make up from the PCB? Oh, there does seem to be an LDO or some... Oh. This might be an LDO. This 3-pin over here. So this guy. And this seems to be some logic chippy. And then we have our sensors and some resistors and capacitors on this side. Okay. So let's unclip this. Let's put this in as is. And we can measure. Maybe we can measure some continuity. Like that. Okay. And then we plug it in. Okay. So as I said, I think this 3-pin over here is an LDO. But then what is what? It's hard to tell. Can't really see from the traces either. Oh wow, that's an SMD connector. Oh, bold. I guess it's held in by the plastic. So we might be able to know what pin is the output by testing on these pins. And then we also might be able to find the ground pin. Okay, let's go to continuity mode. Continuity. Okay. These things are really tiny, so this is going to be a bother. Well, let's first try, I don't know, the cable that's currently in red. So let's snip this thing in here. No. Let's snip this guy in here. There, that's now attached. And now we should be able to... on the caps. Yeah, I'm going to try these legs first. So there's no continuity here. There's no continuity here. Oh, there's also no continuity here. Interesting. Is it still attached? Yeah. Okay, let's try the caps. That's a good suggestion. No. No. So I'm thinking we might have the signal wire now on red. Right? Because... yeah, it might be on the switch. So let's try on the chip. No. 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 Huh. I would have expected some beeps. Okay, that's odd. Let me try on the connector. How is it not making contact? Okay. This is giving us false results. Oh, maybe this wire just isn't contacting properly. Let's try that again. Okay. Now we at least get a beep. So let's try the 3-pin again. No. 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 What? How? Okay, let's try capacitor here. No. Okay. This side of the capacitor is beeping. Same over here. No. Okay. Hey, Dr. Z's is here. Okay, so we know that one side of this capacitor is now beeping, but it's not beeping on the actual thing I'd say is the LDO. No. Okay, let's move over to another one. Let's see if we can do this on the cable. Still not. Jesus. It might be snapping on the plastic. Okay. I'm able to make a connection now. So, middle one. Let's see if that's on what I think is the LDO. No. 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 But it is on one of the IC legs. Okay. Middle pin is data. I think so, yes. Because then this cap wouldn't do anything. No. Okay, so the middle pin beeps on one of the ICs. So that is likely indeed data. So let's go to this one. Check the cable again. Okay, that's a good connection. Okay, let's go back to LDO looking thingy. Okay. So the pin up top here, that is likely ground. And then one is 12 volt or whatever coming in, and the other is whatever is coming out. But this is ground. So then I expect a capacitor to also do it. Yes. Yes, okay. So I think this is ground. So blue is ground, yellow is signal, and red is positive. Do we concur? What do you guys think? Go for magic smoke. So yes, okay, good. Okay, so let me get the power from my bench power supply. So wire in positive here and negative here. Oh, wait, do I have, yeah, I have a different one here. Couple of milliamps, yeah. I'm actually going to switch over to a different block. Is that gonna make sense? No. There. And now I need to wire it the same way. So I need to hold it like that. Okay. Okay. Now let me test that real quick. This one goes in red. Just to make sure we have a good cable connection. Yep. Okay. Yellow. Yep. And then blue. Yes. Okay, good. So let's put the red probe in here and the blue probe in here, or the black probe in the, I guess, and set it to voltage measuring. DC voltage. Okay. Let's plug it in. And power the bench power supply. And wait, I have no idea if this is going to work or not. We'll see. Okay, so let's set it to... Well, let's just start with 3.3 volts. And I set, what, 10 milliamps? It doesn't go lower than 10 milliamps, so 0.01. Okay, let's give it power. Oh, wait, I should wear the glasses of explosion. The middle pin is VN, well, maybe. But, you know, at this point, there's no way to be sure, I think. So, I think we're just going to do this. What sensor is that? They're linked in the video description. But I think this is a distance sensor. I'm not 100% sure. Okay, power. Okay. Huh. It does seem to be outputting a different voltage if I come closer with my hand. See that? Or maybe it's totally random. Or it might not even work because it's not in the housing. I have no idea. Maybe it needs this. Okay, let's turn off the power. Well, that certainly does something. Okay, let's give it 5 volts. Okay. Oh! Oh, look at that. Oh, okay. Okay. So we're giving it 5 volt and 0.01 amp. And currently we're seeing 3 millivolts. But if I put my hand over it, we're seeing 3.2 volts. Okay, that's a definite change. Interesting. What's even more interesting is that it's giving us a 3.3 volt signal and not a 5 volt signal. So let's turn off the power supply. Let's set it to 12 volt. Okay, let's turn it on again. Okay, it pulls it low. See that? 6 microvolts. And now if I put my hand here... Oh, now we're getting 5 volt. What? Why? It's still working. Maybe if I up the amperage. Let's give it 100 milliamp. Okay, it's still 5 volting. It's pretty good. Okay. I know it says 1224, but I wondered if they could work at 3.3 volts. I hoped they would. But it doesn't seem so. Because the logic is also 5 volt. Right? Okay, cool. Okay, let's turn off power. Nope. So, okay, this is a proximity sensor or something like that. Let's try one of the other sensors. I don't know, let's try this one. Because now we can just replug it. Nope. There. 12 volt. Oh, this one is giving a better 5 volt. Okay, okay, interesting. Let's turn off power. Let's see what else we have. We have a PIR sensor. So this guy. Oh, the current draw is basically nothing. It's set to 100 milliamps, but my bench power supply doesn't even register it. Okay, 12 volt, 100 milliamp. Oh, I moved it. Hello? It might be rate limited. Nothing's happening. Okay, let's unpower it. Put it on the disk. Power it again. Oh, it goes to 12 volt. And it goes to 0. Yoo-hoo. Hello? Nope, no smell. Maybe it's rate limited somehow, but I don't know. Right? Okay, don't know how this PIR works. Okay, next. We have this guy. I don't know what that does. I'm still giving it 12 volt, 100 milliamp. And I mean, I can't imagine the pinout being different. I mean... Okay. I need to check what sensor this is. Edit. Go to. So we have sweep hand. Okay, so the first one we tried, this one, it's a sweeping hand sensor. That worked well. Oh, yeah, and you also have a door control sensor, which looks the same. Okay. And this one, oh, this one is a touch sensor. Okay, okay. Oh, it's glowing. Oh, okay. It did something. Eh. It somewhat works. Touch. Okay. Okay, worked. Well, still half of 1.5 volt, but okay. Touch. Okay, 4.7. Touch. 1.5. Okay. Okay. Okay, yeah, sure, it works. Yeah, I'd rather just have a physical button. I'm with Omar Kavula. I mean, just give me a physical button. Just, you know. But okay, this one also works. It also works. We'll try it with lower voltage later. And then we have PIR, motion, PIR motion. Okay, let's plug that in again. You touch it more than 5 times up. Okay, okay. Let's put it on the desk like that. You can't see it there. Power. Okay, nothing happens. Good. Now let's motion sensor it. No. Maybe if I move the sensor. Hello? No. Okay, give it half a minute. Okay. What? Why did it activate while I was drinking? Is it now going to stay active? And why is the output 12 volt instead of 5? A drinking sensor. Well, that'll be cool. Oh, now it turns off. Okay. Wait, so... let's just leave it there. Okay, let's put my hand here. Hello. Okay, let's move the sensor. Yoo-hoo! PIR. A push button. Nope. I mean, I'm pretty sure the wiring's correct. If we look at let's take one of the door control sensors. Okay, let's turn this off again. There. On. 5 volt. No 5 volt. 5 volt. Interesting, Gary. Yeah, so the door control works perfectly. Wait 30 seconds, but yeah, no, the PIR sensor already, you know, if it works like this, I'm not going to use it. So this one works with 12 volt. Let's set it to 5 volt. 5 volt. Go. Okay, 5 volt. So now with 5 volt in, it's emitting, or it's the signal's 3.2 volt. That's actually good for what we want to use it for. Let me set my multimeter to fast. Can I do that over here? Range. 60 volt. There. Okay. So now let's set it to 3.3 volts, because that's what we kind of want to use. No, it doesn't like 3.3 volt. Nope. Well, that answers that question. Can we use these sensors with 3.3 volt? No. You might be able to use it with 5 volt, but none of my boards have, well, some have 5 volts out, but most have 3.3 volts. Bridge the regulator it will. Well, sure, but then, you know, wow, this one now really faintly glows, and it's giving 2.5 volt out. Okay. Oh, it's working. Look at that. The touch sensor does work. It's only 2.5 volt, but if you're looking for high and low, 2.5 and 0.047, that will work. Okay. Oh wow, the touch sensor works. The most crappy sensor of the bunch works. Yeah. Oh, we're going to 3 volts. Oh, that's still fine. You know, we're only supplying 3.3 volts. It's not going to magically make it more volts. There, 0. 0's good. 0's fine. There's still a faint blue glow. See that? Very, 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 very faint. Oh, when it's on. Oh wow, the LED, the ring. It actually reacts with the there. Sometimes it's 3 volts and then it's higher. But when it's off, it's like lower. Huh. So after a while, it somehow charges a capacitor and then it becomes 3 volt and the ring lights up more. That's actually a nice sensor. Huh, cool. Yeah, so if you turn it on, it takes a little bit, and then somehow it becomes 3 volt and the ring lights up more. That's probably not the way it's supposed to work. But I mean, this seems to be reliable. And 2.5 is fine for triggering a high output or a high state. That's fine. Yeah. It's funny how it goes to 3 volt and after a little bit. Yeah, okay. Stop touching the touch sensor. Okay. Well, I declare this one working. Noise. Good. Okay. Did we have more sensors? I don't think so. This is a wire. This is another one of those. Nope. Nope. I think that's all the sensors. Yeah, it's too bad this one doesn't work though. Let's try it again. 0.5. Yeah, no. Nope. Okay, let's up the voltage. Nope. We're at 4 volt. Nope. 4.5. Oh, now it's 0. Okay, let's go down. Okay, it needs 4.4 volts. And then it will, yeah, 2.7. Let's see if it also jumps after a while. No, it doesn't. Okay. So you need 4.4. Okay. So on boards that have 5 volt exposed. You could use this one also as an input on a GPIO pin with 5 volts. So if you have 5 volts, like on a Dig Uno or a Dig Quad, you can actually use these sensors. Let's put it to 5 volt. There. Because this gives 3.2 high. Let's leave it for a while. Yeah, okay, so you can use, and with 5 volt you can use this guy and the button here, but this also works at 3.3 volt. Oh, okay, well that's actually pretty good. Let's try that PIR sensor again, and otherwise we'll open it up. Zero, 5, okay. Zero. It worked twice. And now it's probably in some kind of dead zone. This is with 5 volt coming in. Nope. More power. No, let's leave it at 5 for now. Nope. No, I think it's working. It's just borked. Nope. Nope. Okay, let's turn off the power. Let's turn it on. So now if I swipe it, it goes to 5 volt. And if I swipe it again, it goes to 0, and then it never works again. What? Let's try it again. So, 0, 5 volt, off, broken. One more time. Power. Well, I probably moved it. Okay, hold on. Okay, yeah. Oh, I definitely didn't move it. Well, it's still moving itself. Okay. Okay, let's unpower, power it on. So it's staying at 5 volt. Now it's off. And now it's never going to work again. Okay. Okay, 5 volt. Okay. Let's wait. Okay, this isn't changing, right? Right? So let's do this. Okay, now it changed. So now what? How do I then now trigger it again? Time lapse the live stream, yeah. I mean, yeah, but this isn't going to be useful for anything. Unless it has like a 5-minute trigger or something. I've never understood why you would build a 5-minute trigger or whatever into the PIR sensor. Just make your software do that. Hey. Oh, it went back to 5 volt. So now I can trigger it again. Okay, now we have to wait. It is 2201, 2200, no, 01, Jesus. Okay, 2202. Okay. It's like watching paint dry, but then watching the PIR sensor trigger. Stream. It's the most exciting stream on the internet. Oh, there it went. Okay, so that's about half a minute, I think, then. So now we can trigger it again? Yeah, okay. But the problem is, we're still at 5 volt. And it's outputting 5 volt. So this one you cannot use with one of my boards, because then you'll fry the, the electronics inside, because it wants a 3.3 volt signal. But I now have it on 3.3 volts. Let's see what it does. Okay. So does this one work at 3.3 volts? Let's give it a minute, or half a minute. Yeah, but I don't understand why you would build a trigger relay or the trigger the delay in the sensor. You should build that in your software. Okay, so with 3.3 volts in, it's giving 3.3 out. That's fine. And then, boom. Okay. So PIR works. Interesting. But these sensors work in reverse, don't they? Yeah. Because this one is triggered to ground, and the others are triggered high. Now, the button pins on my boards are also pulled high. So this one would actually work with a button pin on like a AN Penta Mini, for instance, I think. So, pew. Yeah. There's no consistency in these at all. Exactly. These are all bought from the same seller for the same system, and they all work differently. But they work. This PIR seems to be... Oh. No? Oh, it's already triggered. Okay, never mind. Sorry. Let's see if it untriggers. Yep, there it went. Okay. And boo. Okay, yeah. That works. Cool. Okay. So PIR at 3.3 volt works. The touch button thingy at 3.3 volt also works. I know the voltage is 2.5 and then switches to 3 volt later, but that's okay. I mean, that's fine. Yeah. Right, and then we have the magic wait a little bit longer. And now it lights up at... Okay, whatever. But that's also fine at 3.3 volts. Yeah, so if we look at the state, high is off. No, high is on, I think. I don't know. I guess for this one you can determine by yourself. But again, this is at 3.3 volt. And, well, at least you can make it work. Okay, cool. And then we have one of these. At 3.3 volt. And these won't work at 3.3 volt. These, nope, nope, nope. But if we then up the voltage to 4.4, then we suddenly see it go to ground. So now this is off and this is on. That would work, but you need 4.4. But if we set it to 5, there. Yeah, that's still okay, because we're not outputting more than 3.3 volts. I'll hold my finger on it, okay? Sure, we can do that. At least the pinout's the same, yeah, exactly. We have another one of these, but I can't imagine it being different. 3.25. We're at 5 volt in still. Yeah, this turns high if it's blocked, yeah. Oh, right, so you could use it for a closet door. So then high is off and low is on, right? So if the door is against the sensor, it's off. I mean, I'm assuming, yeah, it also works with an object. And then when the door opens, it goes to 0. Oh. So you could use this for a door opening sensor, except it doesn't always work. Okay. Hello? Hello? There is nothing in front of you. But then I have to move the sensor. That's not how this usually works. Okay, maybe it's picking up something. I don't know. Okay. Nope. Oh, okay. Okay, so this one needs 5 volt, but then can at least work. So let's get an AN Penta Mini. Because we have the button pins here, but we only have 3.3 volts. Okay. Do we have one of the blocks that goes in here? I think so. Yes. Yes, we do. Good. So let's prepare that. Now again, on all the AN Penta series, the button inputs are all pulled high. So by default, the button will read 3.3 volts. And then you have to pull it low to actually activate it. Now let's see how that's going to work in this case. So this sensor needs ground and then voltage and then a button pin. So let's connect it. Did anything burn yet? Not yet. So this should be ground. Let's wire them in order, because otherwise I'll forget. Okay, and this should be positive, in our case 3.3 volts. Okay, I think. No. Damn it. That's why I always use wire ferrules. Okay. What? How is that even possible? Right, okay, and then we have our signal. The feral god is giving you some hints, yeah. Let's put that in B1. Jesus, okay. One more time and I'm going to put ferals on it. Is it even opening? Yes. Well, too bad. It's feral time. But I don't think I have ferals that fit these tiny wires. Maybe if I strip them more. Well, and then double it up. So like that. And then fold it like so. And then put the ferrule on it. Not sure how well this is going to hold, but at least it's going to hold better in the terminal. Yeah, these wires are really thin. Okay, I need a different screwdriver. Let's try this one. There. Okay, I think that did it. Yeah, you can get those blocks in all kinds of different types. Yeah, okay. So, okay, oh, we need input power. Oh, I can use this. Good. Good. And I guess we need some kind of LED strip. would be nice. We can use this guy. Or whatever. Come on. Come here, little LED strip. Okay. Now this is a random AN Penta Mini I grabbed from the desk. That's always dangerous. Because you have no idea where it's been, or how it's configured, or if it's even a working one. But we're gonna find out. One short, one long wire. Okay. Is it already fried? Yeah, it came pre-fried. I have no idea. Okay, we've got some LED strip. We've got this, so we can set the voltage to 24 volt now, and this to 5 volt. Positive on this side. Yes, yes, yes. Go. Okay, so now I need to check on my wireless network to see if something came online. Test AN Penta Mini. That's interesting. Okay. 10. Oh, it has ESP Home on there. Cool. Let me share that with you. No. Why are we not doing this? There. Okay, so it has a ESP Home on there, it seems. So LED 5. Yeah, we can trigger that manually at least. That's good. But we also have the button states on there, and it seems like all are off right now. Let's try our touch button. Oh, it said it did some button state thingy. It says it's off right now. And it's on. That's cool. Let me try and make that bigger. See, currently it's on. And the LED is off. And if you touch it, the LED turns on and the button stays off. So I think the idea is that you can see the LED when it's off, and then when it's on, the LED turns off. So like when you're in the dark and you're fumbling for this button, the button is slightly lit up, so you can find the button and push it. But then when the light is on, the light is off on the button and the state is on, so that's good. And then you can touch it again, and then the light turns on slightly, and yeah, okay. Yeah. I'd say this is working great. Okay. Okay, so touch button, usable with AN Penta Mini or whatever AN Penta and Queen LED stuff. Cool. That's nice. Now you're going to run into issues if you want to use multiple buttons, because I only have a single ground and 3.3 volt output. But you have to double or triple those up, and then you can use 3 buttons, but yeah. that seems to be working great. Yeah, autofocus is sometimes an issue. Oh, didn't trigger. Okay. Yeah, perfect. Noise? Okay, cool. So, shall we try the dreaded PIR? I guess so. Okay, so this little touch button thingy seems to be good. Yeah, should I configure? Okay, but then I need to look up the configuration, so I need to stop sharing for a little bit. No, not that one, this one. No, also, this one. Okay. Config to LED strip. Okay. But which Home Assistant is it tied to? Is it tied to a Home Assistant? I know we did some testing recently. Settings, add-ons, ESP Home. Which IP did it get? 107. Okay, let me change that. Because I think it's this one. Save. Yeah. Yeah, I have a testing instance and a production instance. Okay, so let's edit. And I can show you that again. There. And I guess we have a binary sensor for button 1 and it's inverted because high is off and low is on. But then we need to make it do an action. Let me get my browser here. Oh, binary sensor ESP Home action. Thank you. Let's see. Filters, automation, on press, on state. On state? Okay, no, on press. Okay, we can do on press and on release. So we need to add that. On press and on release. And we don't want, we want to turn off. I guess it's not a switch though. On click. On double click, multi-click, no. Or is my light a LED 1, I guess? Right, so my lights aren't switches. So we either want to turn an output on or a light. I think we want to turn a light on. Maybe it's just like light. Oh, okay. That's easy enough. light. Okay. So on press, we want to turn on LED 1, and on release, we want to turn off LED 1. Okay. Save, install wirelessly. Let's go.
They talk about another kind of world. Another kind of world.
What are you afraid of?
That might have been a bit small. Sorry about that. Let's wait for it to boot. Good. Let's refresh this guy. Okay. There. Okay, let's put the touch button on again. There. Doesn't work. Oh, wait. I know why it doesn't work. Okay, never mind. Edit. LED 5. This one had an older configuration where things were turned around. Never mind. Hold on. Yeah, this is actually LED 1, but never mind. I have the GPIOs mixed up. It's okay. Okay, let's go here again. Oh, the button is on. Okay. Let's turn it off. Okay. On. Oh! Off. On. Off. On. Off. On. Off. On. Off. On. Off. On. Huh, works pretty good. We made a button. This touch sensor is actually okay. If this is built into something, or you get these, where is it? These clips to screw them into somewhere. That's pretty okay. Yeah, and it's nice because it has the nice faint glow. Press to hold dim possible. No, this isn't a momentary switch, right? So if you hold it, nothing happens. See that? You actually have to tap it. Because if you hold it, it doesn't do any. Oh, okay. Sometimes it might switch, might not. You see? Now it doesn't do anything. You actually have to tap it. So then you can't do long press, or maybe you might be able to do double press. I don't know. But I don't think it's really made for that. It's not a momentary switch. It's a permanent switch, basically. Okay. So then let's test the PIR sensor. There. Okay, let's leave it there. Okay, movement. Okay, turns on. And now we wait. But that's why I mean this kind of logic should be in the software. Because if we want to have a different period for how long this sensor stays on, well, there's nothing you can do. Okay. So that's about half a minute, I'd say. Okay, let's do it again. Pew. Yeah. We'll test it after this, Chris. Yeah, I'd rather it didn't do the timing. I can do the timing in software, right? Okay, so now it's off again. Good. So let's see if I can trigger it from here. Yeah. And let's give it a 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's trigger it again. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's trigger it again. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Triggering it again. Okay, and now I'm going to stop triggering because it would normally have turned off already. Okay. Yeah. Well, that works. That's fine. That's good. Okay. Cool. Well, if I move it, yeah, okay, it does the same thing. Okay, now let's try the last one, but this one likely won't work. It's this guy. The closet door sensor kind of thingy. Okay. Yeah, no, it is not getting enough voltage to run. Aw. Well, 2 out of 3 isn't bad. Right? I can try another one, but it's probably going to have the same result. No, wave sensor, I think. Oh, wait, no, not the YouTube chat. This one. No, I think I have all of them. Oh, the sweeping hand sensor. Is it this guy? Yeah, no, the sweeping hand sensor on, off, plus dimming. Oh, okay. But they look exactly the same, so I don't know which one is which. But it seems all of these guys. No, these don't work with 3.3 volt. No. We can try the one we took apart. Nope. It's just not make it. It needs at least 5 volt to be able to turn on. Okay. So 2 out of 3. This type won't work. Does not work with 3.3 volt. But it seems this touch button, that works well with 3.3 volt. Works perfectly fine. Even with this, standard length cable you get with it connected. What are you measuring touch sensor with your voltmeter? Does press and hold work? No, it doesn't. It can't, Kavik. It's a permanent switch, not a momentary switch. So if I click this, it holds its state. So it keeps being on. So it won't see. You need a switch that turns off once you release it. That's called a momentary switch, and this is a permanent switch. And with a momentary switch, you can do double tap or long hold or etc. etc. But this guy won't do that. Okay, so that one works well, and we also tested the PIR. So yeah, these two work. This one does not work. Cool. Okay. Yeah. Well, 2 out of 3 isn't bad. I mean, these are useful. I mean, the PIR, I don't know. I just wish we could have used the other one too. Can we trick this somehow? So, oh wait. We could do it the dangerous way. Do we want to try the dangerous way? Yes, we want to try the dangerous way. Did I hear fire? So I was thinking we could hook this guy up to 24 volt. But I'm thinking now that the output voltage is likely going to be too high. So we're going to not destroy my AN Pentamini. So we're going to unclick the trigger wire. There. And then we're going to take the positive. There. We're going to put a ferrule on it because this sucks. And then later I might still try it for science. But we're first going to do the scientific method. We're going to double this up. And put a ferrule on it. Should have put a ferrule on it. Da, 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 da. What? These wires just hate me. Let's try it again. Might need to triple it. Get smaller ferrules, I guess. Okay, need more wire. There. Made a nicely folded package. Yeah, exactly. That's what we're going to do, Medved. But the problem is, what is the output voltage going to be? Because my boards are designed for 3.3 volt in. Okay, let's see if that worked. Nope. Jesus. Okay, we're just gonna bare wire it. I know it's dangerous, but sometimes, you know, no. Yes, yeah, 3 point, yeah, exactly, Dutch maker. So we're gonna wire it into the second positive here. Yeah. There. Yeah, finally. Okay, that's in. And we're gonna measure the output with the multimeter, because I'm a sissy. And maybe later we'll blow it up. But don't know yet. Okay, so we need negative. Yeah. Okay, let's apply 24 volts. And we're going to measure this wire right here. But that's going to be nothing because nothing is connected. Okay, that makes sense. So let's try the touch button and see what voltage we get out of that while this thing is getting 20. Oh, it's a lot brighter now. So this one is positive, this one is negative. Okay, we're getting 4.8 volts, and if we switch it, yeah, so that's the problem, right? We're now getting 4.8 volts on the input to the ESP. So that will likely fry the ESP GPIO open. Okay, so let's try this sensor here. Okay, this like that, this one here. So this one also sees 5 volt. Oh, this is the swipey sensor. Interesting. Is it different than, I don't know, this one? Yeah, this one isn't the swipey sensor. See? Okay, so they are different. This is a swipey and this is a door close sensor. But again, it's sending 5 volt, so not good. But let's try the PIR. So again, this is with 24 volt on the sensor. Well, it's probably already triggered, so now we have to wait. Oh, okay. So this sends 24 volt to the GPIO pin. Let's wait. Yeah, see that? Okay. This one, no. But this one works at 3.3 volts, so that's no problem. This one also works at 3.3 volts, so that's also no problem. So let's do the dangerous thing. Turn off power. Let's screw this guy in. B1, okay. Okay, I think that's in enough. Yes. Good. Okay. So we have the positive connected to 24 volt. We have the negative connected to ground here. And then we have the button input connected here. Let's go to my... yes, this one. Okay. So this will likely kill the GPIO pin, although they are somewhat 5 volt tolerant sometimes. So let's turn on the power. Okay. And let's refresh this guy. Oh, it says it's on. Okay. Well, it's working. What kind of voltage are we seeing? 1.6 minus 3. What? What? Oh, wait, I'm measuring wrong. Okay, so when it's off, when the door is open, basically when it's on, then it's measuring 0. That's good, that's why it's triggering. But when it's closed, the door is closed, so the sensor is off. It's measuring 5 volt. And, well, the ESP won't die from that immediately, as you can see. I don't know how long the ESP is going to survive that, right? Now, there is a circuit on all of my button pins with limiting resistors and things like that, and debouncing, and, you know. So that might actually be helping it. And as I said, the ESPs are somewhat 5 volt tolerant. The pull down, no, there's actually a pull up on that circuit, so... But I'm measuring 5 volt on the port. So 5 volt is going, in theory, to the ESP. Oh, the sensor is actually getting warm, because it's getting 24 volt. It is working fine, though. Yeah. So you can use the button like that if you want, but it also works on 3.3 volt. You can use the PIR sensor directly on 3.3 volt only, because if you do it with the 24 volt trick, it sends 24 volt to that button pin. And this one doesn't work on 3.3 volt, so you have to do 12 or 24 volt. But then it sends 5 volt to the GPIO, so it's kind of, you know, like, your mileage may vary. Oh, let's do the swipey one. How does that work? Oh, maybe I had the swipey. No. Wow, it's switching a lot. I don't think it fully understands here. Okay, that's not well. Let's try that again. On. Off. I don't know how this works. The LED, yeah. So, for some reason, if I do this, it works. But it's a bit confusing. See what it's doing all the time? Okay, so it works, but it's a bit confused when it transitions. Yeah, I don't know. Yeah, when I measured the voltage, it had a sort of ramp up and down. This one works better. So closet door, the door is closed. The door is open. The door is closed. The door is open. The door is closed. I mean, that makes sense. Yeah, okay. We can try our button. Button glows a bit more now. Oh, now it stays on. The light stays on. Because it has enough power now. So yeah, you can use these all on 24 volt. But, you know, at your own risk. Might kill the GPIO at some point. Must be good click or it's bad. Yeah. But the PIR, use it at 3.3 volt. Do not use it at 24 volt, because it'll send 24 volt into that pin over there, and then it's dead. Do we want to try it? Well, okay, let's see what happens. I'm gonna sacrifice my AN Pentamini. My poor AN Pentamini. I guess that's the thing. Instead of the secret today is we're gonna kill this AN Pentamini. Okay. Open the AN Pentamini. Well, you're not gonna see anything. But okay, I'll open it. The ESP is in a shield, so... Hold on. It's not really meant to be opened with the connectors in there. Yeah, I think the original controller these buttons are made for might have an optocoupler in there or something like that. And so that's why they can run 24 volt directly to it. But yeah. Okay. Well, then I'm gonna put my glasses on. Oh, see, this is a modified one because it doesn't have fuse sockets yet. Okay, so we're gonna apply power with it plugged in. I'll put the screen away. This one can go there. 24 volts, 5 amps. It's plugged into 24 volts, ground over here, and then, well, poor GPIO pin over there. Okay, here we go. Nothing yet. No. It's not working. Let's measure it. It's getting 4.45 volts. Oh, okay. How does that work? Huh? So we're gonna have to wait until it turns off. somehow the voltage is getting clamped to 4.45 volts. I have no idea how. It's not in my circuit, but the ESP might be trying to protect itself. So let's try and trigger it again. Yeah. I'm not sure what's going on. All this work again for nothing. Hey, in theory I was putting 24 volts on here, Philip. I really tried. It's a self-learning PIR. So the A input and mini, I wouldn't go that far. Let's check on the output. Yeah, we're doing 24 volts on the outputs, that's for sure. And this one is at 3.3 volt. This one is at 3.3 volt as expected. And this one is at 4.45. I don't know why. I'm willing to bet if I unscrew it, it goes to 24. Let's try and trigger it again. Let's try. Oh, okay. Yeah. It's AI. Okay, let's unscrew the trigger pin. There. And let's measure it. It's still triggered. Still triggered. Yeah, it's probably not able to deliver the current or something like that. Waiting for it to untrigger. "24 volts. So then, okay. Now let's do it while it's on. So as you can see, my port is at 3.3 volts. I moved it, okay. So let's try and plug it in there. Ah, damn it. I moved it. Yeah, but okay, that doesn't matter then. It could be the pull high that it's that the circuit inside of the PIR is so weak that it's being overridden. But yeah, I mean, we did see the others go to 5 volt. So let's check it again. And this is 24. Then. Yeah? No, it's 4.5 volts. 3.3, 3.3. Ground itself, 3.3. Yeah? Okay. So this works. Yeah, this works, okay. But then if I take this guy. Oh, this is the wavy sensor? Yes. Okay. This one's at 496. Wavy? Wave? No. Wave. 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 So that's maybe why it's triggering so weirdly. This has a sort of voltage ramp. See that, going from 5 to 0 and then from 0 to 5 again? That's probably why the button is flickering on and off. That's okay. And then this one should be the closet door sensor. Yeah. All right. Oh, and then we have the touch sensor. Yeah. Okay. Huh. The PIR is getting they're getting a little bit warm at 24 volts on there, not too much though. So yeah, it works better than expected. Sometimes it trigger by itself. Yeah, I don't like the wave sensor either. This one, the closet door sensor, I can understand. I mean, you know, that can work, and the button I can also work. The PIR, I don't like that it's set in hardware how long it stays on. I mean, if that's the right setting for you, that's okay, but I'd rather it just trigger on and off like 1 or 2 seconds so you can set the duration in software basically. And also the re-triggering of the timer, I'd also like that to be in software, but that's me. But other than that, hooked up to 24 volt like this, or you could even steal it from the input, I guess, works pretty okay. It's better results than I expected. Yeah? Yeah. That works well. Okay. Cool. Oh. Well, that's interesting. Maybe I'll do a blog article about this to accumulate the results and also put the warnings there that if you're doing this on 24 volts, I don't know how long it will last. If you're doing it on 3.3 volts, though, that should be fine. Cool. Well, that was worth investigating those, I think. Yeah. Nice. Well, I wanted to do a little fun little stream. It turned out into 2 hours and 17 minutes anyway. That's how things go, I guess. But yeah. I don't really have any secrets today. I guess I already shared some secrets of what I was doing last week in the beginning. So, unless there's any burning questions, I think that's it for this stream. Does anybody have any burning questions? I'm just gonna... You joined especially for the secrets. Well, you already know all the secrets. You're the CEO, so, I mean... Do you have any secrets, Philip? China was good, but we talked about that in the beginning. So, it was very busy though, but it was good. Let me reassemble my AN Pentamini here. Any future FCOMP strips in the work? Well, I guess I could share a secret about that. I've asked World Semi if I could get WS2814 chips, which have half the constant current power budget, and sadly their answer was do not make. And I was like, okay, can you make? I didn't get a reply. So even with my contacts I have over there, I'm not able to figure this out. I know from different chips they have different output constant current drives available. I'd like one for the WS2814. But, yeah, the CEO is like the dumbest one in the company. Yeah, because I really like the current strip. It's a good strip. It's perfect. Except that I'd like to have a high power and a low power version. Currently we have the high power version. I'd really like to make a low power one. But sadly, well, for as it is right now, I can't. So, yeah. The new house plans I hopefully am able to work on again soon. They've been kind of stagnated, so not much news there. How is the food? I really like the food. I don't like the chicken with bones, or the chicken that still looks like chicken, or any meat that looks like what it was when it started. But other than that, I really enjoy the food when I'm there. So 1 million pieces. Yeah, well, of course, they can make anything if you order 1 million. But I think that's not in the budget right now. Later, Nigel. The CEO says there's budget enough. Okay, so let's see. If each chip costs me 10 cents, and I need to order 1 million, that will cost me $100,000. I do not think I will recuperate that. Ooh, sorry. Joined so late. Hope I didn't miss anything awesome. Well, you can look back because the stream is almost done, Pius. Yeah, 30 wafers. Yeah. No, currently Queen LED Incorporated isn't rich enough to be able to spend $1,000 on just that. Sorry. Yeah, but let's see how many strips I'd need to sell. So, if we have 1 million chips, and there's 160 per strip, that would be 6,250 strips. That's a lot. On the DIC quad, can I use the USB-C to power the logic with relay attached? No. You need to use the VEXT terminals. You will take 90k off our hands? Well, then we're talking. The 10,000 I can use. That's no problem. But I want... Oh, wait, Dutch Maker... Oh, no, wait, Philip said that. Okay. Maybe Dutch Maker doesn't agree. You found a better replacement. Oh, okay. Yeah, it's a weird day when you're asking them to make a lower power chip, actually. But yeah. Just pay the CEO less. Yeah, that's right, Philip. If we don't pay your salary for like a quarter year, there's our grand. I mean, you make four grand a year, so I mean, easily, right? So if you could sign on that, then I can order the chips. Ah, 3 channels. Ah, okay, that sucks. Well, when I move, whenever that's going to be, I will scrounge up all the testing boards and broken prototypes and everything, and I'll send it your way. And then you can make like the wall of trash boards for in the new studio. I wish I made 400,000. That'd be nice. You need to make a lot of room in the garage. Well, it's not that big in volume, but you know, depending on how you actually integrate all of it. But by that time, you're done with your house, and I will start moving, and then we can design a backdrop for in the new studio. How's that for a deal? I think that's a good deal. My head's really shiny. You have a 1 meter by 2 meter working table. Cool. That's a good chunk of money, yeah. Connector type on the waterproof cob. Do you know there is a specification page that lists all these things? But it's the JST JWPF. Let me link that for you. QuainLED.info. Digitally addressable. Custom QuainLED cobs. And boom. All the information you could want. Yes, SOP 8 is a bit big for on a strip. If you were earning 400k per year, you wouldn't be here probably. But do you mean you'd be working constantly, or that you wouldn't want to hang around with us plebeian folks? Is that what you're saying, Mr. CEO Philip? What are you saying? Hello, Mr. Quinn. How is your day? My day is it's a bit varied. Currently, it's good. Last time I looked a while ago. Sorry, that's okay, but it's on there, even with a photo and everything. JST JWPF. You can get them on Aliexpress too. But you get a pigtail with the strip, so you don't really have to buy anything, but if you want to, you can. I'd be watching on my 200-inch TV home theater with a fan zone in the back. What's a fan zone? What? What's a fan zone? How was China? China was good. We talked about it a little bit on the beginning of the stream, so you can look that up. We made a lot of progress with CE certifications and things like that. I'm gonna try and put the sensor we took apart together again. Maybe. Ah, okay. Okay, let's squeeze this in there, maybe. Oh, I don't have it aligned. Oh. It went together. Can I plug it in? Yeah, nice. Do you have any plans for some type of Ambilight integration add-ons in the future? I do not. You can use the boards for that, though, with existing add-ons and integrations, but yeah. Maybe we could do a stage and you have to do a live stream on a theater stage with live audience there cheering for Smoke. I would be so nervous. I don't know. I'm not sure I'm cut out for that. I'm really good at talking to the camera as if you guys are there. But I don't know how I would react if you guys would actually be there. Reserving seated, yeah. Maybe I think I'm gonna sponsor Hacker Hotel here in the Netherlands this year. This year? Yeah, I think it's this year. Maybe I could do something there, but I'm really I'm not that kind of guy, I think, so I'm not sure. I don't know what I talk about. I guess about LEDs, but I don't know, man. You think you'd go all crazy with the fans shouting at the screen. Well, you'd be shouting at me, not at the screen. A mosh pit? What? I don't know, man. Yeah, from the data management to LED controllers, yeah. No, I know Dutch Towers, but I don't know. Well, I'll think about it. You know, maybe a hacker hotel is a nice opportunity for that. But then again, it's mostly for like the people who go there, so I don't think they have, you know, day visitors for audience and stuff like that. So, how difficult was it to design your own ESP32 board? It took a few iterations to get it to do exactly what I'd like. I'm actually working. Well, I guess that's a secret, but there might be some updates to the ESP32 board in the future. I'll leave it at that. How to build your own house 2 times. Well, I've only done it once, so that talk is for in a few years. Most of the guys here would probably be too shy to shout anything at you. Just the same as you are to talk to them. Well, then we'd all sit in a room and we'd stare at each other and our desk. Okay, well, bring laptops, yes. Well, I thank you all for hanging out here with me. I'm not sure what we're doing next week yet, either a video or a live stream or nothing, but we're going to see. But I thank you for being here right now, and I will see you guys in the next one. Thanks for being here, guys. Bye-bye.